Hi, this is Algebra 1, Lesson 66. We're starting on page 268, and we're going to talk about the simplification of radical expressions. In Lesson 63, we learned to simplify expressions such as the square root of 50 by using the products of the square roots rule. So we did 50 equals 5 times 5 times 2, which is the product of its prime factors. And then we've said that this was square root of 5 times the square root of 5 times the square root of 2, and these two multiplied together equals 5, so this is 5 times the square root of 2, right? We can use the same procedure to simplify expressions such as this. So we're going to start by writing each of the terms as a product of prime factors. So 8 is 2 times 2 times 2. Minus 50, which we already said was 5 times the square root of 2, plus the square root of 98 is 2 times 49, which is 7 times 7. So the prime factors of 98 are 2 times 7 times 7. Alright, this comes out to 2. This is going to come out to 7. So we have 2 times the square root of 2 minus 5 times the square root of 2 plus 7 times the square root of 2. And now we can simplify this. 2 minus 5 is minus 3 plus 7 is 4. So this is 4 times the square root of 2. Okay, so let's try this one. Let's break these into prime roots. So 18 is 9 times 2, and 9 is 3 times 3, so it's 3, 3, and 2. Plus, and we already said 8 is 2 times 2 times 2. So now we can put the 3's together here, and the 2's together here, and we end up with 3 times the square root of 2 plus 2 times the square root of 2, which equals 5 times the square root of 2. Okay, not too bad so far. Okay, now we have 8 times the square root of 27 minus 3 times the square root of 25. So if we find this prime factors of 27, 27 is 3 times 9, and 9 is 3 times 3. So we have 8 times 3 times 3 times 3 minus 3 times prime factors of 75. Let's see, this is 3 times 25, and 25 is 5 times 5. So we have 3, 5, and 5. We can put these 5 together, and we can put these 3's together. So then we have 8 times 3 times the square root of 3 minus 3 times 5 times the square root of 3. So this is 24 times the square root of 3 minus 15 times the square root of 3, which equals 9 times the square root of 3. Okay, let's try this one. We just figured out that the prime factors for 27 are 3, 3, and 3. So we'll just put that back here. The prime factors for 18 are going to be 2 times 9, which is 3 and 3, so 2, 3, and 3. 6 times, okay, now we have 45, which is 3 times 15, which is 3 times 5. So we have 3, 3, and 5. Boop. Alright, so we have 3 times 3 here, 3 times 3 here, and 3 times 3 here. This is 3 times the square root of 3 minus 3 times 3 times the square root of 2 minus 6 times 3 times the square root of 5. So we have 3 times the square root of 3, 9 times the square root of 2, and 18 times the square root of 5. And that's not going to simplify any further. Okay, now we're going to talk about the square roots of larger numbers. We've been expressing the square root of 50 as prime factors. And we already said that those are 5, 5, and 2, which equals 5 times the square root of 2 because you can multiply these. You can also figure out large numbers sometimes is the product of a prime number and a perfect square. So instead of looking for prime roots, or prime factors, sorry, let's look for perfect squares that are in the root of this. A perfect square is when an integer times an integer equals something. So in this case, we've got 25. So 50 is 25 times 2, and 25 is 5 squared, right? So if you can do 25 times 2, that's also going to equal 5 times the square root of 2. Okay, let's try that. Let's keep going. 10 squared is 100. 100 squared is 10,000. 1,000 squared is 1,000,000. And 10,000 squared is 100 million. You notice all of these have even numbers. So when we are simplifying big numbers like these, we're going to look for one of the factors having an even number of zeros. And I'll show you what I mean. So we're going to simplify 50,000. There are 1, 2, 3, 4 zeros, so we know we can pull a 10,000 out of this. So this is going to equal 5 times 10,000, right? And the square root of 10,000 is 100. So this is going to equal 100 times the square root of 5. In 500,000, there are only 5 zeros. So we're going to leave one inside. Well, we're going to leave one with the 5. So if we make this 50, then it's 50 times 10,000. Okay? And now we can take the square root of 50 times the square root of 10,000. This, of course, is going to be 25 times 2. And this is the square root of 10,000. So this is 5 times the square root of 2. And this is 100. And then we just multiply this together. So it's 500 times the square root of 2. Okay, here we have 40 million. And it has 7 zeros. So once again, we're going to leave one of the zeros with the 40 because there's nothing that goes nicely into that. And we're going to use 1 million as our perfect square. Okay. So we're going to have 40 times 1 million. Because 10 million is not a perfect square. So we're going to use 1 million. Okay. Let's find the prime factors of 40. So 40 is 2 times 20, and 20 is 4 times 5, and 4 is 2 times 2, so we have 2, 2, 2, 5. 2, 2, 2, 5. Okay, and the square root of 1,000,000 is 1,000. Okay, we have 2 2's here, and then 2 times 5 is 10. So this is going to be 2 times the square root of 10 times 1,000. This is going to equal 2,000 times the square root of 10. Okay, now we have simplify 700 million. We're back to 8 zeros. 100 million is a perfect square. So this is just going to be 7 times 100 million. Okay. The square root of 100 million is 10,000 times the square root of 7. And that's your answer for that one. That's it for this lesson. Try your practice problems and let me know if you have any questions. Thank you.